In this lesson, we're going to solve systems by substitution. So yesterday we were solving equations with substitution. However, one of the variables was already solved for either the x or the y. And today you're going to find that they aren't always going to be solved for the x or the y, and so we're going to need to do that. So first of all, it's asking us to solve for the indicated variable. And so we have 9x plus y is equal to 7, and we need to solve for the y. So that means that we need to get this y right here all by itself. So to undo the 9, we're going to, or the 9x, we're going to subtract 9x on both sides. All right, so now we've got y is equal to 7, and then we're going to have just minus 9x. Now we have solved for y. Y is all by itself. And you can't combine that 7 and the negative 9x because they're not like terms. All right, so I'd like for you to pause the video. I would like for you to solve for the x in this equation. So you're going to then get that x all by itself. Then I'd like you to resume the video, and then you can check your work. All right, so to get that x all by itself, we would have added the 4y to both sides, and you would have 1, x is equal to 1 plus 4y. All right, example number 2. How do we solve linear systems using substitution by solving for one variable? So our steps in solving linear systems with substitution is the first step, we're going to solve one of the equations for one of its variables. And yesterday, remember, they were already solved for the variable. Then we're going to substitute the expression from step 1 into the other equation and solve for one of the variables. And then remember, we then substitute that value into one of the equations and solve for the other one. So let's take a look here. Now, you could certainly solve the first one for y by minusing the 3x, but take a look at how easy this one is right here. To solve for the x, all we're going to do is divide by 2. And that cancels out, and we have x is equal to 4y divided by 2 is 2y. All right, so now we have solved for one of the variables. Now the next step then is to plug that value in to the other equation. So we're merging these two equations. So I'm going to take this negative 2. We're saying x is 2y. So x is 2y. So let's take 3 times, we're saying x is 2y. And now we're just going to write the rest of this equation right here. This is the equation we're working with right here. We're just going to write the rest of the equation. So we're going to plus y, or we could even put a 1 there, is equal to negative 7. All right, so 3 times 2 is 6, and then we're going to have the y, plus 1y is equal to negative 7. All right, so we can simplify. 6 plus 1 is 7, so we have 7y is equal to negative 7. And then to get that y all by itself, we're going to divide, and y is equal to negative 1. So we've got one of the values. Now, it does not matter which one of these equations you go back up into. You could go back up into one that you just rewrote. You could go back up into one of the original ones. I'm just going to erase all of this right here so you're looking at what we had to start with. And I personally think that this right here is probably going to be your easiest one to do. But you could certainly, if you want to plug it into the other one, you can do that and you should get the same answer. So let's take 2x is equal to 4y. 2x is equal to 4y. Well, we're saying that y is negative 1. So this negative 1 right here, we're going to plug in where we see that y. So 2x is equal to 4 times negative 1. 2x is equal to negative 4, and we're simply going to divide, and x is equal to negative 2. Now that you've got your 2 points, the solution, remember it's a point, is a coordinate. Our x value is negative 2, our y value is negative 1, so the solution to this system is negative 2, negative 1. All right, question number 2. It looks like we have 2x is equal to 12, and then x minus 5y is equal to negative 29. So let's take the easier of the two. Let's take this one right here. Let's just solve for the variable. So we have 2x is equal to 12. Let's divide by 2. And x is going to be equal to 6. Now, we know the x. This is a little bit easier than the previous one. So x is 6. So what we're going to do then is we're going to take our equation that we haven't worked with. So we're going to take the other equation and we're going to take the 6, and where we see that x, that's where we're going to plug it in. So we're going to take 6, because that's x, minus 5y is equal to negative 29. And now we're solving for the y. Let's minus our 6. Negative 29, we're going another 6 in the hole, so we're actually adding those together. Negative 35. And so let's divide by the negative 5. And y is equal to positive 7. All right, so we've got the y value. Now, it doesn't matter which, well, actually it does here, because we couldn't plug it into the first one. However, maybe you noticed we wouldn't even have to plug it into the second one because we already know what x is. X is 6. Or we could have plugged it into our equation, the second equation there, plug it back in there, and we should be able to find out what x is there as well. We'd get the 6. So our x is 6, our y is 7. So we have 6 for our x and 7 for our y. So the point at which these two lines would intersect is at 6, 7. All right, example number 3. We have 2x plus y is equal to 7, and then we have x plus y is equal to 1. Now, it does not matter which variable you solve for. I would just always solve for the easiest one. I personally think, let's take a look at this equation right here. And I could solve for my x or I could solve for my y. It does not matter. If you want to solve for a different one than I'm going to solve for, that's just fine. I'm going to solve and just get that x all by itself by minusing the y. All right, so now we have x is equal to 1 minus y. All right, so now we've rearranged that equation. So now we have to plug it in to the equation above. So we're saying x is 1 minus y. So I'm going to plug it in right here. So what we have then is we have 2 times x, which is 1 minus y, plus, I'm just going to put that in as a, I'm going to put a 1 on there. 1y is equal to 7. All right, so now let's continue to solve. 2 minus 2y plus 1y is equal to 7. Now we can combine like terms. 2 minus, so negative 2 plus 1 is minus 1y is equal to 7. All right, we're still isolating the variable, so let's minus the 2. And now our last step then is to divide by negative 1. So y is equal to negative 5. All right, so now we've got the y value. And what we don't have then is the x value. All right, and so it does not matter which one you go into. Sometimes it's easier to just kind of clean this up, and let's look at the two that we have. Let's just plug it in. It does not matter. Let's just do it in the first one. So it does not matter which one you plug it into. However, taking a look at this one right here, it's just you're not going to have to divide in the end. So I would plug it into that one. But you can plug it into either one. I'm going to plug it into x plus y is equal to 1. And we're saying y is negative 5. So we have x minus 5, or you can have plus negative 5. That's fine. And then we're going to add the 5. And x is equal to 6. All right, so we've got our two variables. So for our point, our coordinate then, our x is 6 and our y is negative 5. So the point at which these two equations would intersect on the graph would be at 6, negative 5. All right, question number 4. We have x plus y is equal to 10 and 2x plus 3y is equal to 25. Again, we need to solve for one of the variables. And this one is way easier than working with the other one that we have, the 2x plus 3y is equal to 25. So I think the last time we solved for the x, so this time, how about we just solve for the y? We have x plus y is equal to 10. To get the y all by itself, we're just going to minus the x. And we have y is equal to 10 minus x. All right. So now we have to plug this in to the other equation. So we're saying y is 10 minus x. So what we're going to do is we're going to come right over here and we're going to plug it in here. We're going to write the rest of the equation. So we have 2x plus 3 times y, and we're saying y is 10 minus x. And then finish writing your equation. So everything else of the equation should be the exact same, except for the variable that you're replacing. So we have 2x, and then let's distribute, plus 30, because 3 times 10 is 30, and then 3 times negative 1x is negative 3x is equal to 25. All right, now before we take anything from side to side, let's combine. So we have 2x minus 3x is negative 1x plus 30 is equal to 25. All right, let's isolate the variable. We're minusing the 30. Negative 1, x is equal to negative 5. And the negative 1 is multiplying, so we're going to divide. And now x is equal to 5. Because negative 5 divided by negative 1 is positive 5. All right, so we have one variable. Again, let's come up here and take the easier of the two. It'd be way easier to do this one than to solve for the other variable. So if you use the x plus y is equal to 10, we're saying x is 5. 5 plus y is equal to 10. Well, when you solve, y is also equal to 5 because 10 minus 5 is 5. So the solution to this system is 5, 5. All right, so for time purposes, we're going to skip question number 5. All right, question number 6. It says 270 audience members attend a concert. There are twice as many children as adults. How many children and how many adults attend the concert? When we're working with these, the easiest thing for you to do is always assign your variables. And so it looks like we've got two different types of tickets. We've got the children tickets, and then we have the adult tickets. So let's let X be the child tickets and Y be the adult tickets. Now, the first thing that they're saying is that there are 270 audience members, and they're made up of children and of adults. We just don't know how many of each. So you've got your child tickets, you've got your adult tickets. You don't know how many of each, but we know that we have a total of 270 total. Now, the other situation that they're telling us is that there are twice as many children as adult tickets. So there's twice as many children tickets as adult tickets. So that means that the child tickets are equal to twice as many as the adult tickets. So now that I helped you set it up, let's use substitution to determine how many adult and how many child tickets you're going to have. Remember, you know what the X value is, so we're just going to plug it in there. So pause the video and then come back to check it. All right, so after plugging it in, you should have gotten 90 adult tickets, so Y was equal to 90. And then I came and I plugged it back into this equation right here and subtracted it, and I got 180 child tickets. Now, remember it had said that there's twice as many adult tickets as child tickets, and take a look there. 180 is twice the 90. So in this lesson, we took a look at how to solve linear systems with substitution when you have to solve for a variable.